Hey guys, it's Vince. Today in this video we are continuing with volume number 24 of CNC controllers built incorrectly. Now if you're just joining us, the one thing I ask is that you go back and review some of my previous videos in the volume so that you'll get up to speed on reviewing the patterns that many of these content creators follow. The more you can recognize these patterns, the more power you'll have in understanding how they basically pass misinformation from one user to another, and this is exactly what occurs in all of these forums. That's why we see CNC Zone and many other forums like it posting endlessly the same redundant questions, the same issues. It's because one guy sees one guy do it and then it keeps on going. I'm telling you right now, spend your time reviewing these videos if you're serious. If not, there's plenty of other entertainment channels out there. But if you're serious and you want to get that controller built correctly so you're able to produce profit with your machine, this is the channel to pay attention to. Let's jump right in.
Alright, well I finished wiring the portion of the box, the 120 portion of the box, or an electrician would say the line voltage portion of it.
Alright guys, just a brief overview of what you're reviewing. We have a content creator who's retrofitting his mill. We're going inside his enclosure naturally to look at his electronics. Of course, he's using a terminal block, which in his eyes is best practice, which in technical terms it's unfortunate that he's misusing the terminal block. Let me explain. We see that we have crimp connectors stacked inside of terminal block locations. This is incorrect. Terminal blocks are meant to use what's known as a jumper to make multiple areas on the terminal block, meaning the terminals, formulate as one connection. And I'll show you that on my AC terminal splitter from my store. I'll put that on the screen. You can check it out. We do see on the power supplies, we see him daisy chaining components together. Daisy chaining is where we link components through wiring, because I have a lot of guys that ask me what this actually means. You do not want to link multiple components through direct wiring from one to the other. Let me explain an example. Here's a diagram that I built around my IDS Gecko Pro Drive systems using my AC terminal splitter, once again to split power to the power supplies required for these drives and system. And you can see the IEC power input, and we see that's where the power will enter the system, meaning the mains power, and then you can see your ground splitter, and then you can also see where your terminal block is. And that terminal block I'm talking about is the AC terminal splitter. And you can see how one lead comes from the IEC power input, goes to the AC splitter under live, neutral, and ground connections, and then takes all of those individual leads from the IEC power input and splits them so they can be appropriately attached to whatever power supplies are required in the system, along with the power switch, along also with the fuse of the system. This is where you guys need to study. And when I say study, this is a very in-depth diagram, and truth be told, wiring diagrams really take the most time, especially to keep things as simple as possible. This one I wanted to be explicit as far as simplicity, and on top of that, show you guys just how easy it is not to daisy chain. Now, in order to not daisy chain, once again, you see that all leads are individual going to each component, meaning each component is not sharing a ground by simply running a lead from one to the other, meaning a 72 volt power supply to the 48 volt power supply. No, they're actually sharing a lead coming from the terminal AC splitter. And that's appropriate because the AC splitter block will have 4 terminals for ground, 4 terminals for neutral, and 4 terminals for live. So that will support all of your accessories while taking only 3 leads, which is the IEC power inputs leads of live, neutral, and ground, and splitting those individual leads by using the AC terminal splitter into multiple connections. And that's exactly what you see here. If you guys take the time to study this diagram, it will pay you over and over again. I cannot emphasize that enough. And when guys say, well, why do you charge what you charge? Think about the amount of time it takes me to build this kind of wiring diagram. You notice this isn't just a point A to B diagram. It's actually showing you the correct wiring, once again, not daisy chaining. Everything here, if it's done and followed properly, will yield you the best possible system, right down to the ground splitter, which is to be used to connect all motor and accessory cable shield drains. And you see exactly how that's connected. And in this way, everything once again has a single connection going in and out, and everything is yielding one symmetrical loop where each connection is powering a single component. This is best practice. This is due to the fact that if a component fails, it doesn't affect other components. That's a fact. And I'm telling you guys right now, the biggest thing we see with daisy chaining with these DIY crowd, they don't think of, well, you know, if this power supply fails, it could possibly affect other components in the loop. They don't think like that. Why? Because they don't have experience. This is why I'm telling you, be very cautious. And every end user's manual on components with CNC typically state that. I'm going to bring up an excerpt here from Gecko's site where they specifically discuss do not use daisy chaining. The other thing I want to discuss for a final time, hopefully, is using crimp connectors. Crimp connectors, once again, are inherently known to fail, especially used in precision electronics. I always prefer soldering. It is more labor, but a weld supersedes any crimp. Fact. If it's done properly, and properly means with proper technique, solder, and flux. The majority of end users do not do soldering because of the cost, number one, the time, and then the know-how. And that's usually in that chronological order. When you think of assembling your system, most of you want to assemble it one way for life. Unfortunately, crimp connectors, while they're used in the automotive industry in areas that are non-critical or for speed purposes, the thing most end users forget is when you buy a car or you buy a pro-grade machine, and I always hear that thrown in my face, oh, well, you know, I'll challenge you. I'll say pro-grade machines use crimp connectors. Of course they do, because they're not going to invest in the amount of time and labor to do solder connections. They'd rather give you a warranty and make you pay for it incumbent of the price of the machine or the price of the car. Look, if electrical connection fails in your vehicle and it has a warranty, big deal. The dealer covers it. But if you're a DIY guy, you should be thinking I need to be doing it better and cleaner than the other guy because I want my system to be done correctly and perform in a fashion that is predictable. And that means a stable robot. So thinking about it like this will eliminate a lot of these problems from the get-go, pending, of course, you understand it. Don't misconstrue the fact that these content creators understand what they're doing, they just choose something else. Don't believe that. The majority of them do not. They look at it as, hey, I made a connection, I did it right. That's what you see in these videos.
So I took that down, I scraped some of the paint off underneath this screw. I drilled a hole, put a screw through it, stripped the paint under there.
What he's explaining now, guys, is how he ran his ground, and once again is going to hook up multiple components. If you are installing a single ground to ground a single component, a screw within your chassis is fine to do because there'll only be a single connection which provides minimal resistance. If, however, you're hooking up multiple components, you're absolutely right if you said it. You would install a ground bus, which is simply a splitter for that single terminal coming off of the IEC input, and then it splits that ground so that multiple components can once again connect, once again keeping resistance as low as possible, because that's the whole purpose of ground. We don't want a high resistance, we want a low resistance with sensitive electronics so we can dissipate potential EMI, which could corrupt your signals.
And then ran to here. On this I just looped through. I ran.
Correct term is he daisy chained. Study the diagram above.
To this power supply and then ran it over to this power supply. And then on the hot, what we call the hot or the black,
Okay, let's pay close attention to detail in the fact that he is not labeled anything. And that being said, he's also using essentially the same colors for two different hookups, his neutral and his ground. This is not best practice. You should always use the proper colors because it makes it easier for you to allocate what you're connecting. And of course, without labeling anything, especially as a novice, you're really making everything that much more difficult. As the enclosure becomes more populated with components, it makes it harder for you to trace back what component is what connected to. I've stated this many times in the past. When you buy professional, every system should have labeling done to it. Now, if you find that a vendor doesn't do that, I don't consider them a professional, because if you're planning on having your end users service the system, how would they know how everything is connected unless you try to make it proprietary? Now, there are a lot of vendors that still try to do that, in which case their clients would naturally ship back the controller. It kind of locks you in, so to speak, as far as having servicing done. It keeps them always having money in their pockets. You guys have to be aware of what you're watching. If you're a novice, I cannot emphasize it enough, label your connections. It'll make servicing your system faster, more efficient, and of course, you will become more familiar with these connections as you go. Another key point: if this guy was so good at what he was doing in the fact that he's performing content videos on his system, wouldn't it make more sense to show that he knows what he's doing, actually providing labeling on his controller? I mean, it would make it so much easier for his audience to pay attention to, especially when they try to mimic what he's doing.
All right, I got the first part of my 5-volt wiring done. I got I was going to use the same wire I was using before, but it doesn't fit out in the breakout board over here. So I ended up going with, actually these are fluorescent ballast wires. I change ballast all the time, so I have a bunch of extra ballast wires.
So the content creator explains he works a lot with ballast, and therefore he used the ballast wire he had on hand to wire his drives. We all know, or should know, that you should be using the proper double shielded cable to mitigate both forms of EMI present in all shop environments, or any environment for that matter. And on top of that, if you cannot use that or won't use that, you should be using passive filtration through EMI ferrites. None of this has been installed. We also see that he's decided to install a jumper inside of the terminal block. And of course, these terminal blocks on these drives, and all drives, are only designed for a single lead. We see this done by many content creators because, once again, they lack the knowledge to understand you should be installing a terminal splitter in order to, once again, allow for multiple connections when something like this is required with these systems. And we've seen this time and time again, and that's why I tell you guys, watch for the patterns. Look at the volumes in the series previous to this, and you will see the exact same thing. They think wiring simply means connecting a lead from point A to point B and their system is done. This is not drywalling and spackling and painting. And the reason I say that as an analogy, you will get 800 DIY guys, whether it be contractor, handyman, whoever it may be, and you'll get different results from every person. Why is that? Because there's nothing standardized. There's no instructions with that other than a DIY video that's put on YouTube in 20-minute increments, if that. And then the guy covers, hey, I just used this spackle, I went to Home Depot, boom, I bought this brush, I went over everything, and this is it, it's done. Then you'll see another guy do it, and he textures it. Then you'll see another guy do it, and he resands it. It's like I said to you prior. Jobs that require attention to detail, you will pay the most for. If you want to buy a vehicle of very high quality, you're going to find you're going to pay much more for that vehicle because the attention to detail is greater. That is what you pay for. In these systems, keep that in mind when you're looking at purchasing anything from the chassis itself to the controller. It's all based around the level of detail of the company you're working with.
And that does it for that. Now on to the next part. Just to clarify the colors on these coming out of the board, the diagram that I have shows it as green and red.
Now the content creator is referring to the wiring diagram that he's downloaded online. We see many of these guys do this, and it's very unfortunate for all of them that they don't research enough to think there's got to be more to this than a diagram just showing connections from point A to point B. And why I say that is, one must have to wonder why so many posts are on forums with problems if all you had to do is connect leads from one area to another. Guys, there has never been a wiring diagram other than the ones I've created and shown you that show the amount of detail required to assure a properly built system. Most manufacturers don't provide them, and the ones that do, it's only going to be specific typically around their own components, which is completely understandable. When you download a generic diagram, especially ones from overseas, you are downloading a diagram of connections from terminal A to terminal B. That is it. They are not going to tell you how to build your system. I've seen it with VFDs. I have seen it with everything, actually, spindle motors, VFDs, drives. The reason drives are so cheap coming from overseas is because you are not getting the support. You are purchasing directly from a vendor. That is it. They manufacture the drive, they mail it to you, good luck. That's what you're getting. And if you're okay with that and you understand it, then so be it. Unfortunately, in this industry, I've never seen a fire and forget type sale. You will always have to support what you sell, or should, and you, the end user, should be holding accountable anyone you purchase these components from. And that means anybody supplying you with a generic wiring diagram because they themselves aren't willing to either invest the time and money to do it correctly, or they lack the knowledge thereof, you have to make that assessment upon you making a purchase. That's why I tell you the devil is in the details. I can't tell you how many people I've spoken to, whether it be client or potential client, or you'll probably hear it even from these content creators that say, I simply followed the diagram and that's what I built. What they forget is simply following a diagram from an unknown source means nothing. They are not thinking in relative terms to what they're building. They are simply saying, hey, I was provided this document and I am holding it as a user's manual. It is not. User's manuals come with the drives, they come with all your components, or should, and if they don't, and you accept that component, then by all means you accept all responsibility that comes with it unless you return it. And in which case then you say, hey, this is above me, I'm okay with having someone else do it that understands it, I don't want to get involved in that. This is the most frustrating thing when I deal with these content creators, is to see them be smug enough to think you're just going to read a diagram. You don't need any schooling, any background, and any experience. You just need to use this diagram and you instantly have a robot that's worth thousands of dollars. That's why we see so many of these fly-by-night vendors coming to fruition now, because that's what they think. All I need to do is wire this up like they're building a gaming PC and everything is done. Unfortunately, guys, there's way more to it. You don't believe me? Check out the forums. You'll find out how many problems there are.
Done the aviation plugs for the motors. You see that back here. I got all that wired in. I did the soldering. I didn't video the soldering because I'm really just learning to solder.
These content creators never cease to amaze me in what they explain. You guys, I'm sure, picked it up that he explained he didn't film himself soldering because he's still learning. Now, that makes perfect logistical sense. You're learning. Why would you film anything you're learning? You're not an expert. You don't want to portray yourself being an expert or portray that you know what you're doing. That being said, he obviously feels that his CNC controller assembly skills are where they should be, so much so that not only did he film himself and his controller as far as its assembly, but he actually took the next step and posted it on the social media platform YouTube for all of his members of his audience to see and potentially replicate. Now, guys, I want you to really think about what we're seeing here. It's just mistake after mistake. And another mistake we see right before us is the fact that he's utilizing GX16 4-pin connectors. Now, of course, they're missing heat shrink, and this is very common on these content creator videos, where they think that once these connectors are installed within their electronics enclosure, they don't require insulation. This is completely false. God forbid there's a fire. I've said this in previous videos. Fire marshal then calls for an inspection because you know they're going to claim it under their insurance. That's what they would do. And of course, the insurance company will call in their inspectors, and if they find Anything in proximity of where that fire was started that was built incorrectly in any way, shape, or form, you can rest assured they have the best legal teams with the best forensics, and you're not getting paid. You can check up on that with all the major insurance companies and see if I'm wrong. The next thing to point out, using a 4-pin GX16 is completely wrong because you need a 5th pin to be allocated to the shield drain coming from the double shielded motor cables you should be using. We know he's not using shielded cables at all because it would also have a shield drain, and these are 4-pin connectors. So once again, these panel mount male connectors that he has would require that 5th pin so that we would see that ground lead coming to our ground bus installed within our electronics enclosure. And this is a very common mistake. Most guys that are novice just think, oh, I just need 4 pins because my motors are 4 lead. Incorrect, guys. This is where details bite you. And I guarantee you he got this idea from looking at that wiring diagram that was made by God knows who, and he assumed he was doing it right. Well, apparently he's doing it wrong. And we can also see, finally, that he's doing soldering, not use flux, excuse me, and that's why we see blobs of solder. I've stated this before. If you do not use the proper flux when you're soldering, the solder will appear blobby. It will not flatten itself out and level. If the solder is not level and has a chrome smooth finish, it is not done with flux, and therefore that connection is definitely going to be compromised.
Actually, I have already had it hooked up, but and I did the aviation plugs. I think a lot of people use heat shrink, but I didn't have any. I just used electrical tape, but heat shrink is probably better.
It is, as it's the correct component to use when you're actually putting it around your cable at the stress relief. This is the proper practice. And once again, this is an area of concern, and I'm speaking as a vendor now. When we get requests for support, very, very seldom do we get told these type of details. And I want you guys to pay attention to that. Very seldom will an email for a request for support come from a client or a potential client where they'll tell me, hey, I'm using electrical tape on this. Because to them, it doesn't matter. To them, in their mind, they don't think that that would play a role when it could for certain play a role in the potential problem they're having. And the point I'm trying to make here is when you're building precision electronics, which is what you're attempting to do, you should never, ever be wanting to cut corners, because any corner cut will potentially affect the stability of this robot, and that's your whole intent. So again, if you're serious about building a stable production robot, watch every detail and anything these content creators are talking about where he openly says he feels heat shrink would be better, but he still left this in the video and did not correct it. It should tell you what you're dealing with these guys.
Since I seem to have gotten a little better at the soldering part of this, I figured I'd show a little bit of it.
Well, he must be running short on content because now he feels his soldering skills are adept. We, first of all, do not see any flux present on this desk. Let's hope he brings it into the camera's view. The other area of concern I want to draw your attention to is that he's using an alligator clip bare over the casing of that lead. Now, anyone who's worked with electronics will tell you if you do that, you're going to find that that alligator clip could potentially go through that casing, especially when it's heated, when it's attempting to be soldered. So in best practice, you would put a piece of heat shrink or silicone tubing over the jaw to protect it from once again compromising that casing. If the casing is broken, in best practice, it should be replaced, meaning the lead. Now, does he understand that? Does he know that? Apparently not. Let's see where this goes.
I don't know, this seems to be the thing that seems to matter the most, I guess, is getting everything hot enough.
Heat is for certain one variable in soldering, but it's not near as critical as first understanding the proper tools, and flux is a proper tool with soldering. It must be applied to all terminals to be soldered, because when it's applied to the terminal to be soldered, it cleans it. It then allows the solder to form a proper capillary action, and then the end user to achieve the proper bonding strength of the joint. If you don't use it, you're going to have issues with a compromised joint. I will state it again. I've said it earlier in the video. Soldering is a skill set that you can only become successful with years of practice. And I say that because every joint is different. It's not something you're going to pick up in a week where you're going to say, hey, I'm pro level. Usually it's going to, at the very minimum, take a couple months, because you have to do multiple connections and encounter different circumstances where connections may need to be fixed. That happens through trial and error, and that's the beauty of soldering, like many other skill sets, is that it is a true trial and error type skill, and once you get it right, it is dead on. However, don't misconstrue trial and error without understanding that there are actual tools that are required to solder correctly. Flux, a high quality soldering iron, and of course the proper solder. These are fact.
What I started doing was just
2,
making sure
3,
it's hot
4,
enough.
5, 6, 7, 8,
And it's kind of
9,
like
10, 11,
sweating pipe
12,
or
13,
joining
14,
copper water pipe
15,
together.
16, 17,
With that,
18,
you just heat it up and
19,
you
20,
feed the solder
21,
in, and it's
22,
just drawn right
23,
into it
24,
by the heat.
25, 26, 27,
But if you don't
28,
get everything hot,
29,
it'll just
30,
ball up
31,
and it won't,
32, 33,
connect to
34,
all of it,
35,
so
36,
I'm just gonna make sure I heat it
37,
up enough,
38, 39, 40,
and then,
41, 42, 43,
got my,
44, 45, 46, 47,
magnifying
48. 48 seconds before this guy actually made contact with the solder to the joint. Now I want you to think about what that heat is doing to the casing of the lead. This is why understanding the process is so important. He's thinking he's getting a smoother joint by applying more heat. What he's really doing is just cooking the lead endlessly. He brought up a plumber sweating pipes. Guess what? Plumbers use flux. Plumbers understand soldering. What you're seeing here is butchery at its best, and you cannot hack soldering to get it done correctly. Flux should be used. You'll also notice that he's using solid core wire. Solid core wire is not to be used under regards to most component manufacturers' users manuals, because their fear is that after numerous times of having a lead installed, you potentially may fracture that solid core conductor. Now, again, these are the details that one must pay attention to and will actually usually find within the end user's manual of components, pending they're supplied with them. The other point is that this knowledge is attained over you understanding the proper applications for whatever you're working with electronics. And I cannot emphasize that enough. You must proceed with caution when you're watching content creator entertainment videos. Okay, guys, that wraps up volume number 24. Once again, I want to thank you all for your support. I hope that you guys are continuing to learn from these videos. And I cannot emphasize that, once again, had many of these videos not been filmed, you wouldn't believe the stories had I told them to you without seeing it for yourselves. Once again, everyone's skill set is different. Everyone is a professional in their own field. Be very, very careful of what you're working with when it comes to reviewing social media platforms for definitive information on DIY skills. If you select the wrong channel, you guys can be in grave danger of your pocketbook and also your safety. Thank you for your support. Take care.